Hey guys, been a while since a video. Want to continue with the old solar stuff, so I've got myself a lovely new, although it doesn't look it because didn't start very well, MPPT charge controller. This is the 30 amp model. Yeah, the Tracer-3210A. Tried it out briefly with the 100 watt panel I've got, and it's great. Just need to do the permanent installation, and one of the things I do like about this is, as well as the usual array of connections, it's got what they refer to as a COM port. That COM port is a RJ45 style connector. It's a port, RJ45 port I should say, so you can get a connector. Now it's actually RS485, which means there's an RX and a TX, A plus, B plus they're referred to as. So that's no problem, you can get a cable like this, just basically cut the end off a cable, expose the wires, and you need, now it depends. What you need depends on things. I purchased this, which is a really simple, I'm sure it was 99p, I'll put a link down below. That gives you a USB connection and then gives you two little terminal adapters which you screw down. Using that you only need two connections. I'll post a link to the manual, and I'll stick an image up somewhere on the screen. I'm confused with my fingers there, some of your images that shows, but you only need to use a couple of connections. I'll not mention the colour scheme because it depends what colours you've used when you wire it up. Yes, there should be standard, but there's two different standards, so I'll not mention that. So yeah, so you just need two of those connections if you're using that, which is great. But then the only thing is, it's a bit of a pain to then have a USB connection, because I don't know about you, but if you got solar panels in the house, that's great. You can run it down, but you might find that it's not always in an accessible place, so you could be having this in your loft, or in my case, I'm going to plan to have it on a little playhouse, a little outbuilding. So I don't really want to run a huge long Cat5 cable. I've got the cable, I could do it, but then drilling through walls and everything like that, it's, yeah, not what I want to do. So but I do like the software it comes with. It's got some monitoring software. It's a shame it's Windows only, but it's good software, shows you the voltages and everything like that. And again, I'll stick a link up here for where to download that and stick it below. So I had a plan. I do like my wireless things, so I had a look into it and to see if there was anything on the market. There are a few off-the-shelf products, but they're extremely expensive, and to be honest, it wasn't worth that much to me. It's a convenience. So I wondered if it was something possible to make. Initially I looked online and bought a bunch of adapters and did the usual why buy one, buy a few, and I bought quite a lot of these little adapters. You've got the A and B. I didn't really pay attention properly when I bought these. I was sober, honest. But yeah, this is the wrong connection. It doesn't break it out to a serial adapter, which is a bit of a shame. I think this is a Max 485 to RS485 converter, something along the lines. So yeah, that was the wrong one. Never going to work. So toss that aside. I've got 5 of those now. That's lovely. So then I started looking, and what I found was this little guy. You've got your A plus, B plus, and then a negative terminal here, and then on this side you've got your RX, TX, VCC and ground. Now it can be powered off 3.3 or 5 volts supposedly, but so far I've only had any luck with 5 volts, which is a bit of a shame because the ESP runs off 3.3, so we've got two different power situations there. When I initially connected this, what I did was I used this in conjunction with this cable and hooked up the AB connections as I'd been doing previously, and then used a simple connector going from USB serial adapter, so this is a CH340 based board, and connected to that. Now that just didn't work. I was scratching my head for a while. I left it, I must admit, a few weeks and before I got time again, sat down, and then I had a fresh look at it. And that's when I realised that even though with the USB variant you have literally A and B to connect and nothing else, you do have the ground, which I'd overlooked because I wasn't connected on the USB. Once I looked at the manual for the EPSolar and the adapter, it does break out ground on the COM port as well. Once I hooked that up, it worked great. And then the software worked, so that proved that it worked over the serial connection. So then the next hurdle was, once we had that serial connection, was to make that wireless in some variety. So there's some extremely clever guys out there, and there's some coding being done for the ESP8266, and it's called Esp Link, which allows you to use many of different types of the boards, but I'm just going with the regular ESP826601. Nothing super fancy, just works and it's great. So what I've done is I've flashed this up with the Esp Link software. What happens is it's slightly more complicated than maybe flashing it with a Lua firmware or something similar, or doing it through the Arduino IDE. You end up with 3 files. You need to go into the NodeMCU flasher software, specify the 3 files and specify the offsets. Once you do that, I then used my little reset tool, although I still find this very finicky, so I've got some different ones I can show in a later video. And then, yeah, flashed it up. It's great. It goes straight into creating its own access point to begin with. You then go through, connect it to your own access point, your normal Wi-Fi router, and then go. It's configured. It's great. What I'll do is, I've been through that process, so I'll do it again, and I'll insert a video now showing how to do that.
Okay, as I mentioned, we to flash up the ESP8266 for the Esp Link, we need to download 2 files. That's the Esp Link firmware, and also the NodeMCU flasher software. So I'll put links down below, as I mentioned. But basically on the screen here, I've got on the left, I've got the Esp Link software unzipped already, and the main things are the boot _v 1.5 file, the blank.bin and the user1.bin, and we need to flash those 3 files in one go. It's not as complicated as it sounds. It's relatively easy. So with the NodeMCU flasher software downloaded and installed, I've got a 64-bit OS, so I'm going to go into the Win64 folder. Similarly, you would go into Win32 if you had a 32-bit OS. So I'm going to Win64, release, and then I'm going to launch the software. Okay, now this brings across the NodeMCU firmware. Now, I've only got one COM port, which is the serial adapter that I showed earlier in the video. So it automatically selects COM3, which is great. Under config, now it actually remembers the last values you used. You'll notice there's a config folder just above where the ESP8266 flasher executable is there, and it just basically creates that as soon as you make any settings and exit. So you'll notice here, what you need to do is in config, this box will already be checked, that's fine. So you then click on the cog icon, browse to the boot underscore v1.5.bin. Leave the default value to the right, which will be the 0x and then the 5 zeros. Then what you need to do is click the cog icon on the second item and browse to user1.bin. And then you need to change the item to 0x01300. You can actually select these values from the drop down box just on the right, so don't worry. And then you will need to manually check this box as it won't be checked. Similarly, for the third item, you need to check that. And then you need to select the blank.bin, and this needs to go to 0x3FA000. Now this depends on the size of the file that you're apologies, not the size of the file, but the size of the firmware that you can use with your ESP8266. I've just got the box standard, so I can leave the flash size at 4 meg, the baud rate at 230400, flash speed 40 MHz, and DIO for the SPI mode. Basically, it's a case of leaving it like that. What I then like to do normally is click on flash. You notice it does nothing, and then the serial adapter starts flashing mad, and the actual ESP8266 starts flashing. It's receiving things, but it's not in the programming mode. So the program I've got earlier, I'm going to just power cycle that, press the program button, and undo that. Now this is what I'm alluded to in the video. It's a right pain in the bottom to try and get this to work, despite having the proper tool. But what you will see once it goes into programming mode, there. You see this screen change, and what happens is it'll go through and it'll gradually program the device. You'll notice the main changes are that it puts a QR code in the bottom left, and also it changes the AP MAC and STA MAC. Now I think I've clicked one too many times there, and I've actually paused that upload for want of a better description. But you get the idea. That's how you do it. The main important thing is the configuration screen, to have it looking like this. If you do that, that'll work great. I'm using version 2.2.3. Obviously your mileage may vary different versions, but I'll put the links down to the software below. I'm not taking any credit for this software at all. You know, these guys have done it. It's fantastic. I'm more just mashing things up, as I saw someone once described, which I thought was a great analogy. What I have found sometimes is that if you're doing multiple attempts and trying to program in NodeMCU, sometimes you might reset your ESP so many times it's just never going to work. Sometimes it's best just to actually unplug the USB serial adapter and kind of start fresh, so to speak. And actually sometimes it pays to restart the software, because otherwise it's very tricky to see if it's actually reset in the correct mode. But when you restart the software, the QR code's blank, the AP MAC's blank, and the STA MAC's blank as well. So it pays just to do that, and then it'll reset. And then what you will find on the first time that you run it, you'll get a different screen, which will then, you'll then reset it, and then that will allow you to connect to a different screen, basically the web interface of it. So would you believe I got a first time once I've unplugged the USB serial adapter. It's just the way it works sometimes. It'll go through, and the bar will go across 3 times, because it's flashing 3 different bin files manually to the different addresses that we've specified in those drop downs. Once that goes through, we will be able to then reset it. And what it does is it kind of launches an internal mini web server. and then you can connect to that with your machine. That has Wi-Fi enabled, and then once you've done that, then that will enable you to connect it to your Wi-Fi, reboot it again, and then you can access it in your normal network. So you'll notice there you've got the green tick at the bottom, and that means it's great. The bar's all the way at the end. It's brilliant. Done. Okay. What we'll do now is I'll physically power cycle the ESP8266 and then connect to it via the default page, which is 192.168.4.1 if I remember correctly, but I'll put that down in the description as well. Okay, 2.6. Okay, once you've flashed the ESP8266 as I mentioned earlier, and then if you've connected it suitably, and what you need to remember is that it's not a case of just supplying VCC and ground. What you also need to do is to have that jumper wire between CHPD and VCC, and what that will enable it to do is once you power it on, it basically puts it in working mode, for want of a better term. So then if we click on network here, and I've just put a cheap Wi-Fi adapter on my machine here, and then if we click on the network settings here, bring it up, and hopefully it appeared just a second ago. It did take quite some time to boot. Let's see if it appears again. As you can see on my neighbour's Wi-Fi connections. If I come back here, there you go. So what you'll end up with is ESP underscore, and then it'll be a series of kind of pseudo-random digits, which is actually part of the MAC address. So if we click connect on that, it's fully open, so it'll collect no problem at all. And what I did find when I did this initially is that it appears like it's taken some time to connect when it's actually there fine. So 192.168.4.1 I believe. And then it looked like it was taking some time to connect. It's there. First thing I did was to go to pin assignment, and I chose the drop down ESP01, and then what that does is it sets what the reset pin would be. The ISP flash is not enabled because it hasn't enough memory to do over the air flashing. You can do a connection LED. I don't feel that's necessary for what I've done because there's an LED on the unit itself. Yes, it doesn't show connectivity, but all I'm worried about is power in all reality. So if I click change to that, I've left all the other settings to say default, and you've noticed there it came up with a change confirmed box there. Now what we'll notice is that you can change the host name, so you click on that, you can give it any name you want. It probably doesn't matter too much, but if you're going to use multiple of these, I'm potentially going to use two because got two sets of solar panels and two sets of solar controllers. Then what you would do is you would go in, click on Wi-Fi station. Now this is the first thing I did last time, and I ran it in a little bit of confusion here. So if I remember correctly, actually I can do it from the first page I was on. You switch to STA and AP mode. If I do that, and then what it did, it actually was able to scan and find some SSIDs. The issue I had initially was that it just sat there scanning and scanning, and it never found anything. So I'm just going to click off that. Lots of thinking here on its behalf, which I'm not sure why. Hopefully I've not broke it by clicking that setting, so we'll see. Time will tell. Okay, no, it's looking better now. Yeah, you go. So what you'll see is you see a whole slew of options. There's a lot of people use BT in my area, you can tell. So what you would do is you'd click on your option. Actually no, that would be if you're manually setting it. Apologies, password. You put your password in, and then great, it's going to work. You click connect, and then off it goes. Brilliant. Okay, so as I thought, it has actually connected. It's got an internal IP address of this, so we can see it's got its host name, it's got an IP address, this is the IP address it's got, this is the baud rate, and there you go, that's your device flashed. That's automatically in bridge, pass-through mode, whatever you want to call it, and that should work fantastic. The important thing to note is that it's port 23. So in the next step, after we've made the device, I'll do another video that shows how to configure the software for the virtual COM port, and we need to remember both the IP address that it's gained here, and the port of 23. Okay.
Okay guys, I hope that was helpful. It's relatively straightforward. The most complicated thing I find is trying to reliably to get these to flash. Even using a proper tool, I find they're quite finicky. And also beware, I have another tool which is a FTDI based board, and that refuses to flash the 8266s. Don't know why it is. It gets so far through and it's reproducible. It's something like 86%, and it just kills itself. It's silly. So yeah, but once you've got that flashed, that's ready. So now the RX and TX, basically anything you feed into that gets sent wirelessly, and vice versa, for want of a better description. You still need to provide the 3.3 volts in the ground to sort that out, to power it up, but once you've done that, then it should be great. And then my plan is to use a virtual COM port on the machine that's going to run the monitoring software, and then once you do that, you'll be able to connect that virtual COM port, and that virtual COM port will send everything to the IP address you specify. So it'll go to that IP, which is basically the IP of this board, and it'll connect straight to it, and that'll give you all the monitoring options. It'll also allow you to do nice things if doing the configuration, but also remotely powering on and off the load. So it's great. So I've breadboarded stroke hookup wired this. I've just done lots of hookups. So what I plan to do is, I thought it might make sense just to try and put in a little project box, and I could maybe just, you know, velcro this or double-sided sticky tape it to the side of here. So I've got some perf board. It's the stuff I hate, but I've got lots of it. It's cheap, so if I mess it up, I don't mind. So what I will need to do as well is step down the voltage source that we're going to use, and the voltage source is going to actually be supplied over this, which is great. EPEver do an external option, I believe it's the MT50, so that requires power. So what they do is they have two lines are used for power, there's two lines used for ground, and then there's two lines are used for A, two lines are used for B. Now you can either use just a single strand, or you can double them up, whichever you fancy, to be honest. But the great thing is, in the manual it states it's 7.5 volts, but in reality, when I tested it with my multimeter, it was just shy of 5 volts, which is okay. So I've got two options for the power. For the 8266, I can either step this down to 3.3 using pre-done little board, or I've got an adjustable board. I think because of the current draw, I'll probably just use one of these pre-done ones. It's cheating, you know. You could design something a lot more bespoke, but these things are ridiculously cheap. Buy them in bulk. So that'll drop down the power. This does need 5 volts, but that's great because we can feed that straight off the COM port. So we'll do that. You've got the 8266. This is the programming items. I'll put a little block connector so we can remove the 8266 if we need to do anything with it in the future. we aren't going to need him. Another strip that we could maybe use for these guys and for doing some little connections. So yeah, so it's just slightly off on the sizing, so what we'll do is we'll trim it down, so I think from between 16 and 17. Bit more scoring. We're just going to score it down with a sharp knife. Now you could use a Dremel for this, but I just find it kicks up a lot of dust and it gets a bit messy. But then you can see you get a pretty clean cut. Just a few little straggly sections. Doesn't have to be perfect, but you know, it's good. What I'll be able to do is, it actually has 4 holes, but we're not able to use all 4, but in the corner here there's 1 hole I'll be able to line up. Not super important, but just to vaguely hold it steady. So I'll move this big guy out of the way. Okay. So it's a case of seeing what can fit where. So I'm going to need, I'll do that just to raise them a little bit, the Esp266, and we want to try and leave the area under the antenna clear. So you'll just drop down there, and he could go about here, and then this guy could go about here. There's only 3 components in reality. We'll have the wire coming in here. Now, this was the offcut from a longer section that I did, because I originally took an extremely long wire, as you can see. But what I might do is I'll use this other end and trim it, and just to give a little bit of wire to play with, go into the box, and then like I say, we can mount it either on the side of the controller, or alternatively we can stick it to somewhere else. So now the problem always is with these, that is what I hate, it's one-sided. So you've got some copper pads there, but one-sided there. So what we're going to have to do is do all the connections on the back side of the board. And what I might actually try, which might seem silly, is I might try applying some flux. Now I know it's flat pads and it should stick, but with these particular ones I tend to have nothing but problems. Absolute pain. So what I'll do is stand him up that side and go in there. Anything else that might... Nope. Not thinking this through very well, I might. Anything I'll do just to prop it up to make it vaguely level. Okay. This is the point where I forget to put my soldering on, so I'm just going to power that guy on.